Now, before I move on to the application of the identities in solving problems, it's important you know the values of special angles. This is a table showing special angles from 0 to 360 degrees. Now, I am going to tell you I arrived at 30, 45, 60 degrees, because in the last episode I've already explained how I arrived at 0, 90, 180, 270 and 360. If you want to know about that, go back to the last episode. You will find it there. So, but next now is how I know that sine 30 degrees will be 1 over 2, sine 45 degrees will be 1 over root 2, sine 60 degrees will be root 3 over 2. I'm going to show that in the next few seconds. Now, cosine also, I will show that of 30 degrees, 45 degrees and 60 degrees. But how did I arrive at tangent? I will need to tell you that using the identity, which is tan theta equals sine theta over cos theta. The moment you know the value of sine and the value of cos, just divide the value of sine over the value of cosine. It will give you tangent. So 0 over 1 will give you 0, because 0 over anything is 0. Okay? 1 over 2 divided by root 3 over 2 will give you 1 over root 3. You can try that. 1 over root 2 divided by 1 over root 2 will give you 1, of course, because they are the same. Root 3 over 2 divided by 1 over 2 will give you root 3. By the time you do it by yourself, you will get there. Now, all these ones, the two dashes here, means that tangent does not have any value, is at infinity. Tangent of 90 degrees is at infinity. Tangent of 270 degrees is also at infinity. Okay? All right. Now, if you take your calculator, when you press tangent of 90 and tangent of 270 degrees, it will give you syntax error. So you can try that. So how did I arrive at the values of sine and cosine for 30 and 45? Is the next thing I want to discuss now. Come along with me. Now, let's see how we find the values of sine and cosine of 30 and 60 degrees. Here is a triangle with all the three sides equal. Of course, you should know that type of a triangle, that is equilateral triangle. Now, as we know that the sum of angles in a triangle is 180 degrees. So since all the sides are equal, that means all the angles also must be equal. Therefore, divide 180 degrees, which is the sum of angles in a triangle, by 3, because there are 3 angles. You get 60 degrees. That is why each angle is 60 degrees in an equilateral triangle. Now, let's assume that the side of the equilateral triangle is 2 units. 2 units, 2 units, 2 units. So I want to do something now. I'm dropping a line, a vertical line, from the top angle down to the base. Now you can see the red pen. So now, obviously, it has divided this triangle into 2 equal parts. That means this 60 degree here has been divided into 2 equal halves. 30 degree, 30 degree. So I brought out one part of the triangle here. Obviously, it's going to be a right angle triangle because the angle here is a right angle. Alright. If here is 2, that means here will be 1. Because from here to here, which is 2 units, has been divided into what? 2. 1, 1. That's why I have 1 here now. You know how to get this? You use your Pythagoras theorem. Using Pythagoras theorem, that means this side will be equals to 2 square minus 1 square, because this is hypotenuse square minus adjacent square or opposite square, whichever one you call it. That will give you into root. So that means that will be square root of 4 minus 1, which is square root of what? 3. That's how we arrive at root 3 here. Alright. Having shown this, let's now go to find sine and cosine of 30 and 60. From this triangle now, sine 30 degree will be opposite of 30 degree, which is 1, over hypotenuse. I'm using SOHCAHTOA. Opposite over hypotenuse. And hypotenuse is what? 2. That is why sine 30 degree is 1 over 2. Let's have a look at cosine 30 degree. As we all know that cosine is adjacent over hypotenuse. If 1 is the opposite to 30 degree, then root 3 is the adjacent. So root 3 over hypotenuse, which is what? 2. Let's go for sine 60 degree. Sine 60 degree will be opposite to 60, which is root 3, over hypotenuse, which is what? 2. And lastly, cos 60 degree, which is adjacent to 60. If root 3 is opposite to 60 degree, then 1 is adjacent over hypotenuse, which is 2. So that is how we arrived at the values of sine 30 and cos 30 degree. And that of 60 also. Now, let's quickly have a look at sine and cosine of 45 degree. This is a square. As we all know that a square has all the 4 sides equal. So let the side of the square be 1 unit. 1, 1, 1, 1. Now, what do I want to do? And don't forget, the 4 corners of the square is what? All of them are angle 90 degree each. Do not forget that. So that means this is 90 degree, 90, 90, 90. That is right angle. Let me draw a diagonal from one corner to the opposite corner. A diagonal is any line drawn from one corner to the opposite corner. Okay, obviously it will divide the square into 2 equal halves, which will give us a right angled triangle on either side. Now, with the diagonal, I'm picking out one of the 2 right angled triangles. If here is 1 and here is 1, according to Pythagoras theorem, this must be what? Root 2, like I showed the other time. So you can try that also. 1 square plus 1 square equals to square root of root 2, that is the hypotenuse. Okay, and the angle 90 also will be divided into 2 equal halves, which is 45, 45, 45, 45. That is why we have 45 degree here, 45 degree here. Okay, according to SOHCAHTOA, sine 45 degree will be equals to opposite, which is 1 over hypotenuse, which is root 2. Cosine 45 degree also will be opposite, which is 1 over hypotenuse, which is root 2. That is why sine 45 and cosine 45 are the same. In the next episode, we are going to see how we are going to use the identities we have proven so far, the 4 identities, to solve some problems. So this is where I'm going to stop today's class on this episode. If you appreciate the teaching and the quality, please do not hesitate to subscribe to my channel for notification of the subsequent videos. Till then, remain blessed. Thanks for viewing.